Okay, next problem. The are connected in three capacitors are connected in parallel. So C1 equal to 1 microfarad, C2 equal to 2 microfarad, C3 equal to 3 microfarad. Three capacitors, three capacitors, 1 microfarad, 2 microfarads and 3 microfarads are connected in parallel. This is the capacitor and this is the capacitor and this is the capacitor. So these three capacitors in parallel. So connected in parallel. This is that. So connected by a battery. So these three capacitors are connected in parallel. So what is the ratio of charges? What is the ratio of charges? What is the ratio of charges? In this parallel combination, the potential equal to constant. In parallel combination of the capacitors, the potential is constant. That means V1 is to V2 is to V3 equal to 1 is to 1 is to 1. That is the potential ratio. But what is the charge ratio? Charge, we know Q equal to CV. So Q1 is to Q2 is to Q3 ratio, that equals C1V, C2V, C3V. So that equals 1 is to 2 is to 3. So this is the ratio of the charges and potential ratio. When three capacitors are connected in parallel, then potential ratio is constant. That is 1 is to 1 is to 1. And charge ratio is 1 is to 2 is to 3. But in this case, suppose the three capacitors are connected in series. The three capacitors are connected in series. Then the charge is constant. So Q1 is to Q2 is to Q3 equal to 1 is to 1 is to 1. But the potential is different. What is the potential ratio? So we know from this formula potential is equal to C by Q. C by Q. Potential is equal to Q by C. So charge is same, then potential ratio V1 is to V2 is to V3 equal to 1 by C1 plus 1 by C2 plus 1 by C3. 1 by C1 plus 1 by C2 plus 1 by C3. So the potential ratio V1, V2, V3 equal to 1 by 1 is to 1 by 2 is to 1 by 3. So that is 6 is to ratio 6 is to 3 is to 2. So the three capacitors which are connected in series and which are connected in parallel. So in parallel combination, the potential is constant. In series combination, the charge is constant. In parallel combination, charge ratio 1 is to 2 is to 3. In parallel combination, charge is ratio 1 is to 2 is to 3. In series combination, potential ratio 6 is to 3 is to 2. Simply, in parallel combination of the capacitor, potential is constant. In series combination of capacitor, charge is constant. Simple. So, in parallel combination, charge ratio 1 is to 2 is to 3. In series combination, potential ratio 6 is to 3 is to 2. దట్ ఈస్ ద అనదర్ ఫార్ములా, అనదర్ ప్రాబ్లం. సో ఇది ఒకటి అడగొచ్చు, ఇది రెండిట్లో ఏదో ఒకటి అడగొచ్చు మనల్ని. ఓకేనా? సో